Hello Internet, welcome to the world of Zero Arcade. We got started with this project a little interestingly. We started with a live stream. So the live stream we worked on getting sort of the foundation for the actual game that you're going to play in the arcade. In this video, we're going to focus on actually getting the controller working. So we're going to work on making a cross-platform arcade stick that you can download locally and actually configure for your own controller. You can use an actual controller, keyboard and mouse, maybe HTML5 or a game console. Not really sure. We're going to try to support all of them. So that actually leads to the first question. Why are we doing this in Unity? We just need like a really flat UI. We're doing it in Unity for that exact reason, because it'll make it really easy to bring it everywhere. And so even if we wrote something in like Java or something, it doesn't go everywhere. Unity should. So it also gives us a good chance to actually try to make an app in Unity. So this is not going to be a game. There's not going to be any game mechanics or anything in this. It's strictly going to take input and then send it to another service. So we're going to be pulling in a bunch of other components. First thing, I'm going to actually kind of cover briefly what we're talking about. If you've already know kind of about the project, skip ahead because it'll get more interesting after that. So the project is sort of an online multiplayer couch-based arcade game, which sounds like a lot of things that don't really work well together. And so what we're going to try to do is we're going to use some of the technology that's coming out with modern streaming platforms. Specifically, we're looking at Beam. So Beam offers a FTL streaming protocol, which gives you 0.2 seconds of lag between the streamer uploading and you actually viewing it on your computer. So the idea is, let's build a game, I'll run it locally, everybody else will download a controller, and then we can all play it on the stream. And so it's one screen shared across the entire world. At least that's the idea. Whether that works or not, we're going to find out. So we have the game that's being built separately. And then what this is going to do is this is going to be the controller. This is going to be what you will actually use to play the game. So what we're focusing on here is we want it lightweight, we want it quick to download, we want it easy to download, and we want it to be customizable so that people can actually input controls they want. And we want it to run everywhere. So you should be able to run this on Linux, on your Mac, on your Windows PC, on your phone if you need to. Will it work on your phone? It should work on your phone. It should work on your game console, everywhere. Not so sure about some of those platforms. We're going to have to probably do a bunch of tweaking to get it working, but that's sort of the end goal. And then eventually, everybody will be playing the same game, but not the same game, because they'll all have their own little joystick that they configured themselves. So if it all works, that's the end goal. For now, we're here, which is just an empty scene. So the arcade stick, we're going to start off and mostly just get up with the signing in thing. So I've been considering like accounts and things like that. For now, I think we're going to have a username. And I don't even think we're going to force this to be unique. And we're also going to have a location. So I've actually, you can see it there, I've downloaded a super high resolution Earth image. That's just black and white. We're going to allow people to select where they live on this globe. And then the idea is we'll take in our data sphere code that we did previously. We'll bring that in and actually allow a show where everybody is tuning in from. So when you connect, we'll highlight that spot on the map as long as you're connected to the server. And that way you can see on stream where people are connected, which I think will be a really cool way, and it'll kind of emphasize how global this is. And I think we'll see some interesting trends pop up that way. Whether that actually works, I don't know. And there's not going to be any enforcement of that. It's going to be strictly user data. So it's not necessarily going to be accurate, but I don't really care. It's mostly just an interesting thing so we can kind of tell where people are. So we're going to try to get those two features in. We're going to get a really basic text box, we're going to get a map, and then we're going to get a login button. And that should be it, I think. So let's get started. The first thing I'm going to do is actually replace our skybox, because I don't think we need this. So let's do just a skybox. So there's actually two ways to set the skybox. The first thing you have to do is actually select one of the skybox things. I'm just going to use a 6-sided, and I'm going to make it like dark gray. So there's no textures here. I'm not applying a texture. So it's literally just going to be gray. And you should be, in your scene then, to set it, you just drag it in and it sets it. The alternative is if you open the lighting tab. You can get there from window/lighting down here. So if you click that, it'll open here, and this can handle all of your baked lights. So if you need to do like fog or things like that, you can change all of that here. But you can also just replace the skybox by doing that. Either one works. If you just drag it in, it'll do the same thing. That's usually what I do, but that's there as well. So there we go. We've got super boring gray, and we've got a camera. It's actually a perspective camera. I'm going to change it to an orthographic camera, which is going to give us no depth. It's not going to give us a depth of field. And that way, whatever depth we give something at, it's going to look the exact same. So the next thing, let's add a canvas. So Unity redid their entire UI for Unity 5, and it's much better. Still struggles a bit, but it's better. So what you can do is everything is kind of based on these canvases, which can be screen space or world space. And the screen space can either be an overlay or it can be specific to a camera. So the difference is if I make it specific to a camera, you can see it's actually positioned down there. Whereas if I just do the overlay, it actually looks massive, but that's just because it's actually the resolution of the screen. It will fill the entire screen if you do that. And then world space is an actual movable thing. I can actually drag this around now, and it will appear in world space. So if you need to put something in your world that actually is represented in 3D, like if you just need text on the side of a building or something, you can do that with this world space renderer. We're not going to use that. We're probably going to use camera just because I find that nicer. And I'm also going to move it closer just because it's less hard to use. So the plane distance, it just moves things around. One of the things to keep in mind with this screen space camera is it doesn't always work great if you've got this in front of your like if you're playing an FPS, if there's a wall in front of this, it's gonna occlude your UI, which won't happen with the overlay. The overlay will be drawn last. With this, if something's in front, it will draw on top of it. So something to keep in mind. Anyway, I went on a massive tangent, but that's fine. What we want to do, first thing I'm going to just create our world. So we're just going to, it should be relatively simple. We'll just call it Earth. That's a terrible name. What am I thinking? So this is a massive texture, and it's probably going to look interesting. I honestly have no idea how this is going to look. I just needed an Earth texture, so we found one. And then I'm just going to put it at, let's put it at 0. And if we move our camera to -5, they'll line up. And that way everything's sort of in line. It's all zeroed here at the 0Z. And that way if we need depth, we actually have a good reference. I'm going to move it off to the right, because why not? And make it bigger. And then just apply our material. So by default, the UVs for this should be fine. They should just work. And then just to give it some sort of style, we're going to actually make the planet emissive. So it actually shines a bit. So in game, it'll look something like that. And we're probably going to want it to make it so you can actually spin this, which hopefully we'll get to in this video. And yeah, I think that'll look relatively good. We may want to make it a bit bigger, but that's not too hard. There we go. And then all you'd have to do is just click, and you'd put like a little waypoint down there. And then in game, depending on how we set everything up, maybe when it's your turn, it'll show up where you're from, like right next to your name or something. I haven't figured it out yet. We'll figure it out. But that's in the future. I'm just kind of trying to think ahead. There's a lot of really cool things I want to do with this project. So Beam actually offers some really cool features that I think we can take a lot of advantage of. So the next thing, we have this canvas here. Let's actually add some objects to it. So there's a canvas, and then there's these panels, which aren't actually really anything. When you create them, they have an image on them, but you can just remove that, and then it's pretty much just a sub node. So what I usually do is I create a panel that kind of holds my UI elements and kind of give it a place to be. So let's do like 100 and 100. Actually, let's center this and put it on the left side. No, better idea. Let's make a grid. So there's a grid layout group. If I use that, I should, emphasis on the should. Let's not use a grid. Grids need a specific size. Let's go to our layouts and try to find something. I'm looking for something so I can split this in half. So the right side will be strictly the planet, and then the left side will be your username, and then the login button immediately below that. So we want something that can actually split it. I think the horizontal layout group is probably appropriate. So what that will do is if I add 2 more, let's just use buttons for this. What? There we go. Okay. So if I force if I control the child's height and width, they'll fill the entire thing. So this way I can kind of tweak things. We're going to want some margins around the outside, so I'm just going to add those now. We'll just do like 25. And then you can kind of see what this will look like. Obviously, as we change our perspective, this whole thing is going to kind of shift. And I don't know exactly how we're going to handle all of that. We're going to have to be clever about that. But I think we can deal with it for the most part, so we're going to try to. Those buttons were just for show, so I'm going to actually remove those and just add in 2 empty game objects. You'll see instead of the normal transform, they're actually rect transforms, and they're actually automatically positioned due to that horizontal layout group. So the advantage of this is now everything is kind of positioned. We've got our left side, which will be our login, and then we'll have our right side, which will be our world location. And probably just for privacy reasons, the world location will probably make that optional. Obviously, I'd prefer it if people did it, just because I think it's cool. But I don't think making that mandatory is a good idea, because I think it will drive people away. So I'm just going to, we've got our scale set to some massive number, and that's just because of it's based on the scale of our camera now and all of that other fun stuff. But now, if I bring this in, I would have expected our thing to go automatically, but that... I was kind of expecting it to resize with this, but it didn't, obviously. That didn't happen. So, is there a way we can do this better? The answer is maybe. I don't think I can attach a mesh filter to this. I can. So let's do a mesh filter and a mesh renderer here. I'm just kind of winging this. No idea if this is going to work. We're also doing this on the login, which is wrong, but that's fine. And then I'm just going to drag the earth over there. And it's going to be super small, which isn't great. Okay, so what I want to see is, does it resize with the screen? The answer is no. So what I'm trying to do is I'm trying to get it so the globe will actually shrink and contract with our UI elements. I don't know how to do that actually. So I'm actually relatively new to Unity's UI system. I haven't used it that much. I may need to actually take some time and actually research it a little bit. When it came out, I was kind of doing other things, and I haven't really taken the time to learn it. So that's sort of on me. What we're going to do instead, we've got this login button. I'm actually going to plug in a vertical layout group. So this will layer them top to bottom. And so what we can do is we want a text box on top, which is just an input field, I believe. Yeah. So we want an input field. I would have expected that to show up. And then we also are going to want a button. And so the button will appear right below it. Oh, our scale is all kinds of crazy. Okay. So we're not expanding things. We'll expand the width and the height. That looks awful, but we can fix that, I hope. And so we kind of have the basics here. We've got our text box, we've got our button. It's all cool. And you can actually edit things or add things to it. You can click the button, it all works. Can't rotate the sphere yet. We'll get to that. So what do we want to do now? I think we want to make these look less awful. Honestly, that seems like a good idea. Hello, services. Let's do the padding. That's probably not what I want. So there's a number of other layout things so they added this layout, and then there are some UI stuff. The UI is all about rendering things. It's all about like buttons or text boxes or things like that. The layout is going to be strictly for how things appear. So you can do like content size fitters, aspect ratio fitters, which might help with our planet. There's a whole bunch of things. I don't know what the proper one is in this case. It all kind of depends, and I don't know enough to be able to say what it is. I kind of want to put an element inside of here, parent these to it, and then move this in here. And so by doing that, we can create like a login group. But this also gives us the ability, if we expand this so it's all fancy, so it'll take up the entire size of that login area. What we can then do is also set up a total height, which we can do in our layout. And I think I want a layout element. we're going to have it a preferred height, say 100. Why not? A minimum height, say 100, and a flexible height of 100. And then we want to so part of the issue is it's automatically resizing to be way too big. That's kind of weird. Let me just click all the buttons. That'll probably solve this. Because I would expect the min height means you can't shrink it further than that. The preferred height also makes sense. And then the flexible height, we've got that. And we're not forcing it to get any bigger. So why are these so wrong? I want it centered. And okay, it's automatically going to override all of my choices. I'm kind of confused why that didn't work, honestly. I expected it to, and it didn't. Which usually isn't a good sign because it means I don't know what I'm talking about. Is there something else that I should try? Content size fitter. Preferred size. Whoa. Yeah, this makes less sense. So this, we can obviously tweak it manually. I was kind of hoping that it would just be auto magic. This works. Can actually just take that out now. We don't really need it. But that does what we wanted. Doesn't do it the way I wanted to do it, but it works, I guess. So now our game looks something like this. We've got the planet over there. We've got our button. I'm not running it, so you can't actually click anything. If I do, you can click it. I can type here, the world. Everything still works. It's all laid out. Should be adaptive. So as we resize it, it's kind of funky, but whoa, that was super funky. But this seems all right. I don't like the planet not resizing, but we'll have to get to that later. I don't know how to solve it yet. I'm assuming that the UI gives us some way to solve that. We could write a script to do it. I don't want to do that. So the next step, probably allowing us to control this planet. So I'm thinking right click to kind of drag it, and then you click with the left mouse to kind of place your pin. So we'll have to figure out how to do that. Yeah, sure, we can do that now. Why not? So let's do a planet grab. Yeah, we'll just call it planet grab for now. So what this is going to do is this is strictly going to allow us to rotate our planet. For part of the issue we're going to run into is controllers, for example, aren't going to be able to use that very well. We're going to need something else in order to handle that. Don't know what that's going to be. Maybe just a target and you just kind of rotate the planet until it's under wherever. Obviously, we could pull in like using all sorts of different like GPS or whatever. We could figure out where you are. But that people don't usually like it when you do that, especially if it's not required in your app. If you just start taking people's personal information, they don't appreciate that. So let's avoid that unless we need it. Resharper's asking me for all sorts of fun stuff. So, all right. Hello. Thank you for that. I really wanted you to show that. That's great. Cool. Thank you. All right. So now we have all of that. Let's do planet grab. This is going poorly. So the first thing we're going to want to do is we're going to want to cast a ray. When you right click to actually grab the planet, and then as long as you have grabbed it, then you can rotate it. So the delta of your mouse, if you've grabbed the planet, is going to be the rotation. So we want this to be a private bool of grabbed, I guess. So this will represent if you've grabbed it. So if for now we're actually just going to do hard inputs. Eventually this will be configured and we'll probably abstract this away. But we're not there yet. This is bare bones stuff. We're not there yet. So mouse button down, or just mouse button actually, of 1. So this will be your secondary mouse button. Right click for most people. Unless you've got a left-handed mouse, then it'll probably be left click. Anyway, that's too much information. Input.get mouse button. If it's down, this will be true as long as you hold it, which should be good for us. What we want to do is if it's not grabbed, we want to see if we've grabbed it. So this is the wrong place to do that. We're going to want 2 of these checks, which is gross. I know that's gross. But what we want is if this is going to prevent us, so if we're holding the right mouse and we just kind of swing by, we don't want the planet to just kind of go flying. We want it to be an intentional action. So if the mouse button is down, then we'll test if they've grabbed it. Otherwise, this will be if they've grabbed it and if the input.get mouse button is 1. If it's not, then we can actually just set grabbed equal to false. So this logic is a little bit funky. We only want to set the grab to false if the input, or if the right mouse button isn't down. What we're actually doing is setting it false if it's not grabbed or if the mouse button isn't down. That doesn't really affect us because if it's not grabbed, it'll set it to false, which we don't care about. So that's a little sketchy. May want to come back and fix that later. But for now, I think it'll work. And that's what we need. So we need to do some physics stuff, which is going to be a ray. So we want to create a ray here, which is pretty easy. We actually don't do it that way. We do it with camera.ray something. We've done this before. Screen to ray. No. Got main. There we go. Screen point to ray. So we want to take the screen point of our mouse and translate that into a ray based on our current camera. So we're going to plug in our mouse position here. And that's actually going to get where our mouse is on the screen. And then we'll translate that automatically into a ray. We've got the raycast hit, which we'll just store there for now. Then if our raycast hits anything, well actually if it hits the current object, then we want to rotate it. So we're going to do if the ray has an out of hit with a max distance of, we don't care about that. So that actually should be enough to get us everything. We don't really care about the max distance. We just want it to cast a ray. If it hits it, good. And then the last check, if our hit game object. Where is that? Good question. We can get the collider, oops, or the rigid body. So there may not be a rigid body. Let's grab the transform, because that will have a game object on it. Or we could use the current one. We're going to compare game objects though. So we can do this dot game object. So what we're testing for is if we hit whatever the script is attached to. So we want to attach this to our planet, and then it will see if we've grabbed it and then rotate it. So if it is, then grabbed equals true. Cool. That was way too much work, but we got there. So the next fun thing we want to do, what do we want to do? I'm considering if we want like velocity. Do we want to be able to like throw this and kind of have it spin more? I think that'd be fun. So let's do that. Let's grab require component type of rigid body. So we're going to require a rigid body here. And then we're going to use that and actually apply a force to that. We're going to apply a torque based on the mouse movement, and that should actually spin it. We're going to have to make sure it doesn't actually move. So we're going to have to definitely lock those positions, but other than that, it should be good. So let's do rigid body there. And then we can, in our start actually, do rigid body dot, what do we want to do? Get component. There we go. We're going to grab our rigid body. And then with our rigid body, we can actually pull that in there. And then for the movement, let's just apply a torque. So rigid body dot add torque. And we're going to add it. It should actually work in world space. Just because of the way the camera is positioned. We'll know pretty quickly if this is wrong. And actually, we can do this better. We can do, if we're going to apply 2 torques, actually, we're going to do one along the camera's x-axis, so one to the camera's right. So we're going to get the main camera, do the transform dot right. So this is going to get the right vector of our camera. And then we're going to multiply that by our input dot mouse. We want the delta, which means we're actually going to need to get an axis here, which I believe is mouse x. And so that should add some force based on the mouse's movement. How much? I don't know. We're going to find out pretty quickly. And then the other one is going to be up, and that way we can actually twist it that way. If we want to limit these, we'll write a separate script that'll actually prevent it from rotating too far. This script we want to keep simple, so that's it. And so we should just be able to attach that onto our world, and then it should just automatically let us grab it. We attached a rigid body. Oops. Let's turn off gravity. That's probably a good idea. And let's freeze the position. That way, even if something weird happens and it does get an actual force applied to it, it's not going to go anywhere. And we definitely don't want it going anywhere. So we've got it there. Okay, I don't see it moving. Yeah, I definitely don't. Doesn't appear to be going anywhere. And that's because we removed the collider. Oops, again. I've been doing that a lot. Okay, cool. We've got a collider again, so we should actually be able to hit it with our raycast. And I think we're rotating along the wrong axes and relatively slowly. We can tweak all of that. So I'm going to expose a public float grab strength. So we probably will want to edit this at some point so that it actually aligns. So based on where you move it, it actually kind of feels like you grabbed it and moved it around that circle. We're not going to do that yet because that's just more complicated. But for now, we can actually have a grab strength here, which will rotate it. And then I flip these. So there's an axis here. What I was doing, like adding torque to the right when you move the mouse horizontally, that's not how it works. You're adding torque around that axis. So we're spinning around the right axis, which means we're going this way. And then for the up, we'd be spinning this way around instead of going that up. So just keep that in mind because I totally forgot that. So that's set to 0. We can change that. Grab strength, let's set that to 20. So it's backwards, but it does work. We can kind of totally mess up our sphere and let it go. And everything seems to work. So eventually, somebody will be able to grab this and then point out where they want. I'm going to add some really quick drag here. So this way it will actually slow down over time. And so you can kind of flick around, be like, oh, look, the United States, and click, and then you're good. We'll add waypoints and things like that in the future, and we'll probably add saving and stuff for that, so you don't have to do it every time, because that would be a pain. But yeah, there's that. And you can definitely totally live in Antarctica if you want. Also an option. So yeah, I think that's it for this video. We kind of got started. It's obviously not the most entertaining project, but it's going to be cool once we get it all put together. This is one of the projects I'm really excited about because I don't think anybody's tried something like this before. So if you've got any ideas on where we can take this or any other ideas, this entire project is open source. It's going to be on GitHub. So this is going to be going up there probably later tonight. And the actual game is also going to be there, also open source. You can modify it. Hopefully pull requests will work. So if you've got ideas or if you have a separate game that you think would be cool with this idea, we can pull that in. That's not ready yet. That'll come after we get sort of proof working. But yeah, if you've got ideas, let's hear them. But that's it for now. So until next time, see you, Internet.